Hello, everyone, and welcome to our webinar. Our topic today.
Thank you, Mark. Our webinar today is about the use of engineered wood products in applications other than the construction of buildings. We'll be looking at how various wood products are manufactured, their structural characteristics, and lastly, how they may be used in products made for sale, handling devices, or systems. APA is a nonprofit trade association that represents the manufacturers of structural engineered wood products, including plywood, oriented strand board or OSB, glue laminated timber, wood I-joists, and structural composite lumber. This slide shows the four divisions of APA, which are quality services, technical services, market communications, and my division, field services. My role as an engineered wood specialist in the field services division is to provide information and recommendations to construction and design professionals. Here is the group of products that make up APA's family of engineered wood. They range from a wide variety of wood structural panels to floor joists and roof rafters, or structural beams and columns. Wood structural panels include structural plywood and oriented strand board, or OSB. We will spend much of our time today detailing what these panels are and how they can be used outside of construction. The remainder of our time will be spent covering the structural composite lumber products, including laminated veneer lumber, or LVL, parallel strand lumber, or PSL, and laminated and oriented strand lumber, or LSL and OSL. The common denominator for all of these products, including panels, is wood fiber that is bonded together with resins. APA has developed a website specifically for these products and their applications in what we classify as industrial use markets. The address is performancepanels.com. The Performance Panels site contains information about the various engineered wood products, their performance characteristics, and the known applications for these products. There are links on the site that send you directly to the websites of all of the manufacturers of these products who are members of our trade association, APA, the Engineered Wood Association. Let's begin with wood structural panels, and that includes both structural plywood and OSB. Many of you have probably seen the APA trademark that is shown here. We'll examine the information that is found on the trademark and how that information can be applied to applications outside of construction. So the focus of this presentation is on industrial applications, but we will briefly touch on construction. The most common uses for wood structural panels is as floor, wall, and roof sheathing, and this is in both residential and commercial buildings. These products knit the other framing members together to create rigid systems that resist the forces of wind and earthquakes, as well as gravity loads, keeping the occupants safe and protected from the elements. What does the trademark tell us on this performance-rated panel? This image is from the latest Engineered Wood Construction Guide. First of all, the recommended application, which in this case is floor sheathing. Secondly, the maximum distance between supports that this panel can be used as intended according to the building codes. The larger this distance, the stronger the panel in resisting gravity loads. Next, we see that this product has tongue and grooved edges so that one panel can provide support to adjoining panels with the net width of the surface being 47.5 inches. The bond classification relates to the moisture resistance of the glue bond. Numbers 8 and 9 give the minimum thickness of the panel and the manufacturer's identification number. The lower part of the stamp includes the standards the product was manufactured to, which in this case is PS 119, and the performance category as related to the panel thickness range, which in this case is 23/32. Although the trademarks are intended for use in construction applications, they can also be helpful when considering the use of performance-rated or other wood structural panels in products such as strong, lightweight upholstered furniture frames or durable engineered wood pallets. Wood structural panels are most frequently manufactured under two standards: PS 119, which is the voluntary standard for structural plywood, and PS 218, which is the performance standard for wood structural panels. PS1 provides performance and prescriptive requirements for structural plywood. PS1 covers a wide variety of grades. Those grades include sheathing, concrete form, marine grade, and sanded plywood. Under the performance standard, or PS2, both structural plywood and oriented strand board are required to meet performance criteria for specific designated construction applications. These applications include floor, wall, and roof sheathing. PS2 panels include a wide range of panel configurations and compositions that allow a more efficient use of raw material. So PS1 panels are only structural plywood, and PS2 can be either structural plywood or oriented strand board. Plywood is comprised of veneers or plies that are bonded together with moisture-resistant adhesives under high heat and pressure. Each veneer grade is determined by appearance in terms of natural, unrepaired growth characteristics and the allowable number and size of repairs made during manufacture. Here we see veneer letter grades of A through D. A and B veneers have solid faces with limited repairs and knots. C and D veneers have allowable voided areas of wood with C grade openings limited to mostly 1-inch knot holes and D grade limited to mostly up to 2.5-inch knot holes. There is a C plugged veneer grade that improves a C grade veneer with repairs of knot holes and limitations on other open defects. So A, B, and C plugged faces are nearly solid and they're sanded if they're A or B, touch sanded if C plugged. C and D faces have greater openings and are not sanded. Veneers are laid up at the mill in plies consisting of varying grades of veneers depending on the final product they are producing. A layer is defined as one or more adjacent veneer plies, each with the grain running parallel. Common veneer thicknesses are 1/6 of an inch, 1/8 of an inch, and 1/10 of an inch. The outer veneers are referred to as the face and back plies, with the better grade of veneer being the face. The inner plies can be referred to as the core or crossband plies or center ply. The orientation of the strength axis or grain is very important in the fabrication of plywood to ensure dimensional stability and structural properties. The direction of the grain in adjacent layers is oriented in perpendicular directions as the panel is laid up, while occasionally, as with a 4-ply layup, the direction of the grain of adjacent interior plies are parallel with each other. The direction of the grain of the face and back are almost always oriented to the longer dimension of the panel and create the strong axis or direction of the plywood panel. All of the veneers are bonded together with a moisture-resistant adhesive under heat and pressure. This creates a panel where the veneers work together to form an integral unit. In this depiction of plywood, there are 5 plies and 5 layers. Again, Two adjacent plies with the same grain orientation make one layer, so a 4-ply panel always has 3 layers. The construction of wood structural panels is defined in the standards and therefore provides the users with panel performance that is both consistent and reliable. There are limited deviations in all dimensions, including the width, length, and thickness. The panel must be relatively square with straight, uniform edges. There are other workmanship requirements, including the quality of the repairs to the veneers, the types of fillers that can be used, and many others. Again, standards provide you with a known quality of product. So let's talk about bond classification. Exterior panels have bonds capable of withstanding permanent exposure to weather or other conditions of similar severity. Exposure 1 panels are suitable for uses not permanently exposed to weather. Panels classified as Exposure 1 are intended to resist the effects of moisture due to construction delays or other conditions of similar severity. Exposure 1 panels may also be used when exposure to the outdoors is on the underside only, such as roof overhangs. Although appearance characteristics of the panel grade should also be considered in those applications. Exposure 1 panels are made with the same moisture-resistant adhesives used in exterior panels. However, because other panel compositional factors may affect bond performance, only exterior panels should be used for long-term exposure to the weather. Pictured here is the moisture cycle test for bond performance. The PS1 and PS2 plywood specimens have cuts made into each side of the panel to expose one glue line. They are placed in a vacuum pressure vessel that replaces the air in the wood with water to fully soak the sample. The samples are then placed in a machine and pulled apart at the exposed glue line while saturated. The result of the bond test is shown in the photo. Structural plywood bonds are expected to be stronger than the wood itself. In this bond specimen, the dark colored areas show the glue line and indicate where there was bond failure. The lighter colored areas are the wood fiber and indicate wood failure. In the exterior bond test, specimens on average no more than 15% of the failure can be at the glue line. For exposure 1 test specimens, there can be no more than 20% bond failure. OSB adhesive bond is tested by assessing the bending strength after 1 or more cycles of water saturation. In order to pass the bond classification test for OSB, the bending capacity of the prepared samples must meet an established level of bending strength. Table 7 in PS2 lists the required bending levels for the different performance categories of OSB panels. Once again, bond performance is related to the bending capacity of oriented strand board, or OSB. So our first test question of the day: what bond classification of plywood should be used in the manufacturing of this over-the-road vehicle? And obviously the answer is exterior, because you're going to be consistently exposed to the elements. We don't have time today to review all of the different tests that PS1 and PS2 wood structural panels are subjected to, but they do include bending, impact resistance, fire, dimensional stability, and fastener withdrawal capacity. Because of the PS1 and PS2 standards, the reliability in performance and dimensional sizes are much greater than those products that are not manufactured to standards. APA panel products with similar trademarks are readily available across North America and much of the world. And because of the uniformity and closely monitored manufacturing, there is much less waste and lost yield when incorporating wood structural panels into your finished products or systems. Standardized products provide well-established and known levels of performance. APA has design tables with data on bending stiffness and strength levels, axial tension and compression, shear and plane, rigidity, and shear through the thickness. Industrial engineers have the information that they need to determine the structural capacities of all of the PS1 and PS2 plywood and OSB panel products that they are evaluating. Here are 3 common trademarks that are found on locally available panel products. On the left is a PS2 performance-rated sheathing panel. In the middle is a PS1 sanded plywood panel, and on the right is PS1 plywood panel with an MDO or medium density overlay on the face of the panel. There are several plywood grades specified in PS1, and here are some common ones. The letter graded panels refer to the veneer grade on the face of the panels, followed by the veneer grade on the back of PS1 plywood. Sheathing is a structural use panel intended for floors, walls, or roof. It includes a span rating with permitted roof and subfloor span or stud spacing. Underlayment is a panel for floors that has a stronger or supported face layer. Structural one panels are designed for use where enhanced structural performance is required. Siding is used for exterior cladding of buildings. Marine grade panels have only B grade and better veneers of Douglas fir or western larch throughout the panel. Concrete form is intended to be used in forming concrete and is available as overlaid or with B grade faces. There are 2 grades of overlay panels in PS1. Medium density overlays, or MDO, have resin impregnated cellulose fiber faces. The face sheets must have a minimum of 34% resin content. The surface is more durable than the raw wood, and the overlay masks the imperfections in the panel surface when exposed to moisture. MDO is available in 2 grades, concrete form and general. HDO, or high-density overlays, also have resin-impregnated cellulose fiber face sheets that must have a minimum of 52% resin content. The surface of HDO panels are harder and more impervious to impact damage. They also come in 2 grades, concrete form and industrial. When used for concrete forming, HDO panels usually have more reuses than MDO, and the finish on the concrete is smoother. For industrial applications, the HDO panels are more durable and chemical resistant than other grades of plywood. PS1 panels can be manufactured with many different species of wood. For prescriptive construction, the species are broken down into 5 group classifications, with Group 1 species being the strongest and densest. Both southern yellow pine and Douglas fir are Group 1 species. If you find Group 1 listed on the trademark of a sheet of plywood, both the face and back veneers are Group 1 species. So what is a Structural 1 panel? Structural 1 panels have increased shear and stiffness capacities, especially across the width of the panels. Structural 1 plywood is composed of all Group 1 species of wood. Structural 1 is available in both plywood and OSB. Several factors impact the structural performance of the panels. Face and back layers of plywood and OSB are almost always manufactured with the grain or strands oriented to the length of the panel, which creates the strong direction of the panel. For floor and roof construction, the panel's strength axis should always run perpendicular to supports. The thickness of the panels, the species of wood used in the panels, and other construction considerations also impact the strength and stiffness. The span rating in a structural use panel is an indication of the structural performance of that panel. In some applications, such as with a captive pallet in high-density storage uses, it's important that the panels stay flat, even if not fastened to supports. While composite panels made from layers of plies or strands are generally more stable than solid wood, cross-laminating the plies enhances the dimensional stability. The more layers or plies and the thicker the panel, the more stable it is. Balancing the panel also contributes to the stability. This refers to the number and thickness of plies above and below the center of the panel, and also using similar species of wood in those areas. There are other manufacturing variables, such as in overlay panels, where there is often a less expensive overlay placed on the back of the panel to make it less likely to move out of a flat plane. Both plywood and OSB are commonly manufactured in different sizes and thicknesses. While the common size of the panels are nominally 48 inch by 96 inch, plywood can be made in widths up to 60 inches and lengths to 10 feet. Secondary scarfing of plywood is available in some specialty markets. On the other hand, OSB, which is made in large mats, can be cut into many different sizes. Common panel thicknesses run between 1/4 of an inch and 1 1/8 inches and may be available in oversized mats up to 24 feet long. When considering the durability of the surface of the panels, potential loading conditions need to be considered. If concentrated or point loads are anticipated, panels can be manufactured that are more solid or homogeneous, like OSB, or a grade such as underlayment in plywood that has a more solid second ply supporting the face. In addition, stronger species of wood could be used on the face. Another consideration is surface wear with foot traffic, but also when rolling equipment is used. In those cases, the maximum load, the surface area of the load, and the type and size of the wheels must be evaluated. And again, surface enhancements can be used to protect the panel and provide an extended life. Sometimes the surface texture needs to be determined for handling or aesthetic reasons. There's a wide range of textures beginning with widely available sheathing panels, which are usually not sanded and may have open defects in the surface of the sheets. Some panels have a touch sanded finish, which is smoother and more solid than the surface of sheathing panels. The next step is a sanded plywood panel that's also solid and sanded smoother than touch sanding. And the smoothest would be panels with overlays. There are also panels manufactured specifically for appearance as exterior or decorative siding panels. These panels have a variety of surfaces such as rough sawn, brushed, sanded, and overlays. Siding panel surfaces can be flush with no grooves or have grooves either 4-inch, 8-inch, or 12-inch on center. Curved surfaces with shallow saw cuts or wide reverse board and batten appearance are also available. Because these are wood panels, they're relatively easy to bend or curve, drill, cut, or route, and can be fastened with a multitude of various mechanical fasteners, dowels, and adhesives. Panels can be attached through all 6 sides. Obviously, attaching to the face or back is the most simple, but edge fastening is also possible. Edge fastening can be enhanced by using an increased number of plies, manufacturing a more solid panel by minimizing gaps between adjoining veneers, or using a more homogeneous product with strands or higher grade veneers throughout the panel. The surfaces of plywood panels can be enhanced with many compatible surfaces. Often, laminated materials increase the durability of the surface of panels as in industrial floors. A hardboard surface can be laminated to the face, creating a wear-resistant grade of panel called Plyron that is available from several manufacturers of plywood. Steel and other metallic sheets can be laminated in secondary processes like the center photo of plywood that will be used in the floors of mass transit rail cars. On the right are samples of plywood having different thicknesses and types of plastics laminated to the surfaces to increase the durability of the panels. Plywood and OSB have replaced lumber components in products where wider pieces were needed and dimensional stability is important. Similar to lumber, plywood and OSB are easy to shape and fasten and have a high strength to weight ratio. The panels come in uniform dimensions with tight manufacturing tolerances, and their level of performance is known and reliable. And most grades of plywood and OSB are widely available in North America and many other parts of the world. Similar features of structural panels have worked well in the transportation industry. Both these photos show panels used for floors for mass transit vehicles. Panels can even be used as wall liners for truck trailers and seats and backs for chairs and benches. In addition to the features mentioned here, the panels are strong, moisture resistant, and have consistent quality. In materials handling, we again see these features adding value. Solid panels better protect contents, provide impact resistance, and they are light in weight and easy to build and repair for reuse. In export packaging, no additional treatment to control pests is required due to the heat and pressure applied during the manufacture of the panels. So we've just covered the more traditional uses for plywood and OSB, but there are many other uses for strong, flat, durable products. The family of engineered wood products also includes structural composite lumber, or SCL, which is made up of laminated veneer lumber, parallel strand lumber, laminated strand lumber, and oriented strand lumber. These products are manufactured by layering dried and graded wood veneers or strands and flakes with moisture-resistant adhesives into blocks of material known as billets, which are resewn into specified sizes. Structural composite material that is manufactured by APA members are certified with an APA trademark. The mark signifies that the manufacturer is committed to a rigorous program of quality verification and testing. The information in the trademark may vary depending on the manufacturer and type of SCL. APA product reports and ICC-ES reports help design professionals and manufacturers determine a product's conformance with code and national, international, or industry recognized standards. APA issues these reports to document the compliance of an engineered wood product that is manufactured under a quality program audited by APA. The many advantages of structural composite lumber include flexibility in structural orientation. They are uniform in size, lighter in weight than metals and plastics, dimensionally stable, straighter and longer lengths than lumber, and they have known and dependable structural capacity and are easily shaped and able to be connected with most types of fasteners, and they're non-metallic. LVL is a widely used structural composite lumber product. The wood veneers are bonded together so that the grain of all veneers is parallel to the long direction. The LVL billet is then sewn to desired dimensions depending on the in-use application. Because LVL is made with scarfed or lapped jointed veneers, LVL is available in lengths far beyond conventional lumber lengths. From the forest to the mill, let's look at how laminated veneer lumber is manufactured. After the logs are harvested from the fields, they are transported to the veneer mill. After debarking and cutting to length, the logs are heated in conditioning ponds or steam vats to soften the wood. Next, the logs are peeled on a rotary lathe to create a continuous sheet of veneer so that it can be clipped to size. The veneers are then dried and visually graded and evaluated for strength and then sorted. Veneers enter the layup process based upon its strength characteristics to achieve the target LVL grade. Glue is applied and the veneer is stacked in a process that randomizes the effects of natural wood characteristics. The LVL exits the press and is then cut to its desired length, which is called a billet. Samples are taken and tested through the quality control process. The billets are cut to size with rip saws. Moisture sealer and stamps are applied, and finally, products are packaged for shipment. PSL is manufactured from veneers clipped into long strands laid in parallel formation and bonded together with an adhesive to form the finished structural section. The length to thickness ratio of the strands in PSL is around 300. Like LVL, this product is used for beam applications where high bending strength is needed. PSL is also frequently used as load-bearing columns. Similar to PSL, laminated strand lumber is made from flaked wood strands that have a length to thickness ratio of approximately 150. LSL is used in a variety of applications from framing members to millwork components. We will now take a closer look at the process to manufacture laminated strand lumber. Laminated strand lumber, or LSL, is primarily made from aspen trees. This species grows very rapidly in the northern states and Canada. Logs are transported to the mill and are cut to 9 feet lengths. The cut logs are then submerged in conditioning ponds. The logs are then sent to the flakers and cut into strands. The strands are dried and blended with adhesives. And this process is monitored and continually controlled. The strands are oriented lengthwise and dropped into mats. The multiple layered mats are cut into the press sizes. The mats are then moved on to the steam injection press. The press mats are then cut into billets for handling. There are quality control checks done in the mill to ensure proper glue bond. The samples are also tested for strength. Then the billets are cut into custom sizes with a rip saw. The rip members are then dimensionally checked to ensure uniformity. In the last step of the process, the product is edge sealed and packaged for shipping. Traditional structural composite lumber products are manufactured in many combinations of lengths, depths, and thickness. The most common thickness is 1 3/4 inches wide by 48 feet in length, but the product is made in a variety of thicknesses from 1 inch up to as thick as 7 inches. With the width of the billets 48 inches or more, there are many possible widths and depths of structural composite lumber. Common SCL depths match construction uses of 5.5 inch, 7 1/4 inch, and 9 1/4 inch, and deeper, with lengths being limited only by the ability to transport. The strength and stiffness of the member is based upon how the member is used for its application. The member thickness, depth, design properties, and orientation needs to be considered in selecting the correct structural composite lumber product. The larger the modulus of elasticity value and fiber bending, the stronger and stiffer the SCL member. As mentioned earlier, all of this information can be found on the APA website in their product report. LVLs are made in low, medium, and high strengths. LSLs are made in low and medium strengths. PSL is only made for high strength uses, and OSL is made for lower strengths, but still offers the consistency that engineered wood is recognized for. So when you're determining what product will work best, it often depends on what type of application you are designing. Engineered wood products have nearly unlimited uses and are easy to work with. Structural composite lumber can be cut or routed with unlimited patterns. The best part of all is that engineered wood products are very easy to work with and can be fastened and adhered to similar or dissimilar materials. This photo shows one of the many uses for structural composite lumber. In this example, SCL is being used as vertical and horizontal framing members. SCL members are available in much longer lengths than traditional lumber. Laminated strand lumber can be manufactured up to 64-foot lengths and is manufactured in uniform shapes that are resistant to bowing or twisting. Structural composite lumber materials can be used in a variety of applications, from furniture manufacturing to millwork components. Unlimited, unique, and creative ideas can be imagined with engineered wood products, such as beautiful commercial furniture. Work tables fabricated with engineered wood will last for decades and stand the test of time. And wood always offers an inviting space and makes guests feel welcome. Structural composite lumber has many benefits, such as its superior strength and stiffness attributes. Moisture-resistant adhesives are used for manufacturing, and most all structural composite lumber products are made with additional waxes and sealants applied to the entire surface of the material, ensuring dimensional stability. All engineered wood products are produced in a highly controlled environment and thoroughly tested to ensure uniform, consistent quality. I would like to now circle back to our performancepanels.com website. This site is designed to give you the information needed to select the proper product for your in-use application. There are sections on the site devoted to concrete forms, furniture, material handling, and transportation. As you narrow your selection, you will find links to a list of APA members who manufacture a wide variety of product types and options. I would also like to point out the Panel Features tab at the top of the Performance Panels site. This section provides more information on not only different panel types, but also panel properties, such as acoustical, fire resistance, chemical resistance, weight, and many others. So before we move on to our question section, I'd like to make sure that you're signed up to receive our APA Update newsletter. This will ensure you're notified of future webinars as well as updates to APA publications and standards. To receive it, all you need to do from our homepage is to click on Sign in the upper right-hand corner of the page. In the drop-down menu, simply select Register, and then you'll need to tell us what you'd like to receive from APA. And in this case, that's the APA Update newsletter. Additionally, APA has resources to assist you at our help desk that can be reached through email at help@apawood.org or phone at 253-620-7400. We also have APA field staff located throughout the country that are available to share the experiences and technical expertise to help design professionals, builders, and code officials prevent and solve problems related to the use of engineered wood products in residential, multifamily, and commercial projects. In the industrial market, we work with industrial engineers, packaging engineers, and purchasing agents. Their individual contact information can be found on our APA website, apawood.org. Please feel free to reach out and take advantage of this resource. This concludes our presentation on ABCs of EWPs. At this time, I'll turn it back over to Mark, who's been monitoring questions.
Thank you, Warren. Some questions did come in while you were speaking, Warren, and we have a little bit of time now, so let's see if we can answer some of these. First question, are these products able to pass standards for formaldehyde off-gassing? I'm guessing that this is related to the California Air Resource Board requirements or the CARB requirements.
Yeah, that's a good question, and it's certainly a hot topic of conversation. So your structural plywood, which be specified to PS1, and for that matter, any wood structural panels that could be specified to PS2, they've all demonstrated such low levels for off-gassing that they're actually exempt. And this applies to products audited under APA's quality assurance program. And this does apply to products used in both industrial and construction applications. If you'd like more information on that, we do have a technical note titled Formaldehyde and Engineered Wood Products. Easy way to find that is if you visit performancepanels.com and search formaldehyde. You can download the document, and it'll also bring up other resources that we have on this topic.
This next question, Warren, is about the manufacturing standards for panel products. We heard both PS1 and PS2 mentioned during the presentation, so what is the difference between those two standards?
Yeah, okay, so PS1, which, as we mentioned, is currently PS119, that covers structural plywood only and does not cover OSB. So it's a standard that covers things like veneer grading, adhesive bonds, wood species, panel construction and workmanship, moisture content, dimensional tolerances. PS2, which is currently PS218, can cover all wood structural panels, so both plywood and OSB. This product standard primarily establishes structural criteria, and it covers performance requirements, adhesive bond requirements, panel construction, dimensions and tolerances. And again, this standard covers both OSB and plywood.
Thanks, Warren. The next question that came in is, can OSB be used for concrete forming?
That's an interesting question. So to start with, OSB is always an exposure 1 bond classification. So as we covered earlier, this means that that panel should only be exposed to moisture during normal construction process. These exposure 1 panels are not meant to be exposed to repeated wetting and drying. So if you think about it, if OSB was used as a concrete form, it would likely be for 1 pour only. And that's generally not what people are looking for with concrete forms. They usually want them to be reused. So an exterior bond classification is probably going to be desired. And this is going to lead you to plywood panels with a minimum C grade veneer, as well as panels overlaid with MDO or HDO.
Our next question is, you mentioned that a 4-ply panel has 3 layers. Can you explain what that means?
That can definitely be a little bit confusing. So if you think about the direction of the grain of the plies, they're going to be perpendicular as the panel is laid up. So, as an example, if the grain of the face ply is running in the long direction of the panel, which it almost always is, the next ply's grain is going to be oriented perpendicular to the direction of the face ply. And this same process is followed from the back of the panel as well. So if this example was a 4-ply panel, the 2 plies in the center or core would have their grains running in the same direction. So if 2 adjacent plies have parallel grain, we call that a layer. So this 4-ply panel has 3 layers. If we did exactly the same process on a 5-ply panel, all of the plies would be perpendicular to the adjacent ply, so we would have a 5-ply, 5-layer panel.
I think we're going to have time for one more question today. So Warren, why would you use LSL instead of an OSL product?
When selecting really any engineered wood product, it's really important to know the requirements of the application. I mean, that's really critical. So addressing this question specifically, comparing LSL and OSL, you need to consider the strength needed for the end application. LSL is available in both low and medium design strength, where OSL is limited to lower strength. And then you also you want to consider product availability, whereas OSL, it's possible, is not as readily available as LSL. Something else to consider.
Thank you, Warren. Before we conclude, I'd like to touch on a couple of things related to, first, a short survey, and secondly, 2 of APA's websites. First, we'd really appreciate receiving your feedback via the survey that you will receive shortly. So please take a minute, fill it out, and your comments will be used to improve these educational experiences like the one we're sharing today. And finally, make sure that you visit both our performancepanels.com and APA.org websites. The Performance Panel site was developed specifically for out-of-construction market applications and concrete forming, while the APA.org website is APA's main flagship site. I should mention that if you have technical questions on any topic related to the use of engineered wood products in out-of-construction and concrete applications, don't hesitate to go to the performancepanels.com website or contact the APA Help Desk at the address shown here. Thanks again for taking part in our webinar. As mentioned earlier, in a week or two, a recording of today's webinar and answers to the questions that were asked during the webinar will be posted at performancepanels.com. And with that, I'd like to thank you for attending. Have a great day.